Hey everyone, welcome back. In this video, we're going to continue the series on creating a full stack trading app, and we're going to be talking about SQL and how to write queries to populate and manage our database that we created in the last video. Before I jump into the SQL code, I wanted to quickly, again, I'm going to do this in every video now, point out the website, hackingthemarkets.com. There's a message board, link to all the videos, link to the GitHub page with the source code, and there's some information about an upcoming course if you want to sign up for the mailing list to express your interest. And there's also a donate here if you want to buy me a coffee to make a contribution. And just recently, I want to thank the people that just did this. Thank you to Greg Richardson, who bought 10 drinks for me. I didn't even know that was possible, so thank you for the extremely generous contribution there. He said thanks for your great work, and he learned a lot from the alpaca videos, and so he's looking forward to it. So there's definitely going to be tons of new videos. I hope to finish this year at over 100 videos, and then next year I want to make 100 more, so we're going to have a really big library if you keep following this channel. Thank you to Greg, and also thank you to Sean, who is very interested in a full stack application and is excited about this series. So yeah, lots of great comments on the videos so far. So I'm really excited about continuing this series. So let's get into it. So I have the second article here that I'm going to publish at the conclusion of this video. I've already published the first one, the written tutorial for full stack database design, and I included the SQL to create the database and also the little sketch that we drew out. So here's the tutorial for the last video if you want to catch up to where we are. Part 2 here, we're going to talk about SQL. So in part 1, we created the database itself and the tables, which were just containers for the structure where we'll store all of our records. And so in this tutorial, we're actually going to start inserting records, selecting them, updating them, and deleting them. So SQL. So the way I thought I'd start this out is to talk about Crud Operations. So if you've developed web apps, for instance, before, you've probably heard about CRUD interfaces or CRUD operations. And CRUD stands for create, read, update, and delete. So these operations are the building blocks for literally like millions of web and mobile applications. So if you can design user interfaces or create APIs and write queries that perform these basic operations, you can build your own applications and be employed for your entire career. So yeah, once I learned CRUD operations, so how to query a SQL database and manage data in it and create user interfaces to manage that data, and also APIs to interact with that data, you know, you're pretty much set. This can be your entire career if you enjoy this sort of thing. Because think about any web application you use, like let's say Twitter.com, for instance. So here's my Twitter page. We're creating, reading, and updating and deleting records all the time. Every application is like that. So what is a tweet, right? I'm creating a record in a database somewhere, and there's a relationship in that data. That tweet is owned by a user account, which is a user record, right? So each tweet is owned by a user, so it'll reference a user, which is the author, and then there's comments that each reference a tweet. Same thing. So think of it in a relational database format. They probably use another type of database, but just saying. So when you tweet, you're creating a record. What about the read part? Reading is just reading all these tweets, selecting them out of the database. So I'm reading and scrolling through a tweet, so I'm getting many records. Or if I drill down on one of my individual tweets, right? So if I click this, right, I'm reading one record. Or if I read my feed, it's reading many records. If I write a tweet, it's creating a record. Twitter actually doesn't let you edit tweets. So maybe that wasn't the best example, but you can delete tweets, right? So you can delete, but you can edit other things, right? I can edit my profile and edit my user settings, right? So I'm creating, reading, updating, and deleting. So think about any app, you can probably think about how these CRUD operations apply. So Yahoo Finance, for instance, you know, I'm reading in a list of stocks. I'm reading a single stock here. When I sign in, I can edit or update my preferences, right? I can probably add some records to my watch list. I can delete stocks from my watch list and so forth. So any application, Facebook, you know, you're creating a post, it's going into a feed, it's being read by all your followers. Yeah, so not to beat that to death, I'm just saying, if you think of any application, at its core, a lot of apps, business applications, social applications are just creating, reading, updating, and deleting records in a database and building user interfaces to do that are nice and easy to use, right? And so how do we implement these CRUD operations in SQL? So there's 4 basic statements that we want to learn. We want to know how to select data. We want to know the insert statement. So we want insert, select, update, and delete. And if you can do those 4 things and master those, you can do a lot, actually. You can build a lot of your own applications and implement your own ideas. So let's start out where we finished last time. So we should have a database already, right? So I go back to my projects directory, and I was in this full stack trading app directory. And we typed SQLite 3 appdb, and that created our database, and we logged into it. And then we issued those create table statements. And so now if I look at my schema, you'll still see those tables are there. And so the way you read records in SQL is with the select statement. So I type select. It's not case sensitive, but often you'll see me capitalize them because I like to capitalize the reserved words in SQL. So anything that I came up with, I use lowercase, but I type capital letters for like create table because that's part of the SQL language. But you can just type it lowercase. So let's just do lowercase. So I can do select star from stock, for instance, right? And you'll notice nothing happens. So I'm trying to select all of the records in the stock table, but there's no records in there yet. So the first statement we're actually going to learn is the insert statement. And this lets us insert records into our database table. And so I have these statements here. So you see we have the SQLite prompt, and I just want to copy one of these. So I can do insert into stock. And see my mistake there. I didn't copy the I. So do that, right? And it says insert into stock. So I'm saying I want to insert a record into, you put the table name, our table name is stock. And then in parentheses, you put the column names that you're inserting values into. So I'm saying symbol, comma, company. And then I put the word values. And then in these parentheses, I put the actual values that I'm inserting into these columns. So the first column is symbol. I'm inserting Apple into the symbol column and the company name Apple into the company column, right? And these are in the stock table. So now when I insert into a stock, that value will be in there. And so now I can do select star from stock, and you'll see it returns that record. So that record is inside of our database table. So let's insert a couple more. So let's say we want Microsoft, Tesla, and AMD. If I press up on my keyboard, you can see my history, and I can just edit this real quick, and we'll just reuse our same statements. So I'll say Tesla. We can do, actually, what order did I do? I'll do Microsoft, Tesla, AMD. So I'll do MSFT, Microsoft, and these are in single quotes because they are text strings. If they're a number, you don't use quotes. Okay, so I'm doing Microsoft, I'm doing Tesla, and AMD. So let me do both of those. Tesla, so there's my company name. And I'll make some mistakes. You want a comma between each value. And we also want AMD. Okay. Advanced micro devices. Okay. So we do that. I inserted 4 records, and that's how you insert. And that's all there is to it. And remember, we have a primary key in our table. So if you look, we have ID, symbol, and company. You notice I didn't insert the ID myself, but since we specified ID is the primary key for this table, SQLite automatically increments this value. So when I do select star from stock, you'll see we have a primary key of 1, 2, 3, and 4. So it's automatically incrementing a unique number to identify this record. Okay, so that's how you insert or create records. So think about it. If you created a web form, right, where you wanted a user to enter in a stock symbol and company, or enter in their name, for instance, all you're doing when you click that button to like submit the form, it's actually hitting a web route or backend, and that route is just issuing a SQL statement to write insert into, and it's taking whatever was in the web form, right, and just placing that into the SQL query dynamically. And I'll show you how to issue SQL statements with Python in the next video to let you hook that up to a web front end. All right, insert, create. That's the first thing we're doing. Then we're going to read data with the select statement, right? And so we showed the select star from stock. And that wildcard star means select all columns. If I just wanted the ID field, I could do select ID from stock, right? And I'll get 1, 4, 2, 3. Not very useful. That's useful a lot of times, but not very useful right now. If I want multiple columns, I can do select ID, comma, symbol from stock, and that'll give me just the ID and just a symbol. But since if I want to just dump the whole table real quick and show it on the screen, I can do select star from stock. In the previous video, I also mentioned that select statements in SQL allow you to aggregate and slice and dice your information in a variety of ways. So we don't have to just select all of these records at once. We can select a single record by using a where clause. So I can say select company from stock where symbol equals Tesla. And you know, it's pretty intuitive. It's very almost like English, right? Select star, or I can select company, just the company symbol from, or just the company. If I just want the company name from stock where symbol equals TSLA. And that'll give me the name Tesla, right? So I'm selecting a single column from a table where some condition is true. So I'm looking up where symbol equals TSLA, and that gives me Tesla. If you don't have an exact string you're trying to match on, there's a like statement. So if I want to do select company from stock, if I want to only select the companies that start with the letter A, I can do where symbol is like, and you can use this percent for a wildcard. So I can do a percent like that, and that'll get me Apple and Advanced Micro Devices. So it gets me everything that starts with a certain character. Or if I just want a wildcard on both sides, and I put percent on this side, and I do ICRO, right? That will get me nothing because I said where symbol is like. But if I said where company is like, Microsoft and Advanced Micro Devices both have ICRO in them, so I selected both of those. So if I wanted to implement a simple searching capability, and some search engines are much more sophisticated than this, but a very simple searching or autocomplete capability would let you, if you type the letter A into a form, so let's say Yahoo Finance or Google Finance, I type the letter A there, right? It might come up with a list of symbols. Let me do Google Finance real quick. Yeah, so I type the letter A, right? And that pulls up Apple, Amazon, Alphabet, right? And so what if we wanted this autocomplete functionality? I create a web form. I have this hit my back end, and my back end code could run a query like this. And since the user typed the letter A, we just select all the symbols that start with the letter A. Do that, we get the result set, return it back to the browser, and render this cool dropdown, right? So that's kind of how that would work. Okay. What else we got? How else can we select data? We can select, if we don't want to select all of the data, we can select using the limit. So let's say we want to select star from stock and say we only want the first 3, right? That would limit our query set to 3. If we had like 1,000 stocks, for instance, a lot of times you don't want to show everything at once. Most of the time you don't want to show every single record in the database. If we had 10,000 stocks and we wanted to page through them, like page 1, 2, 3, 4, you might select them 10 records at a time. So you'd use a limit. So limit 10, and then you could do a limit and offset to get the next 10, and so forth. Same way when you're browsing through your tweets, it probably selects like the first 10, but you scroll down and it loads more and more. And that's how you browse through records, by fetching more and more in a database. Okay, so we covered that. Limiting, we can select on a specific ID. We can select that contain a substring. We can also sort. So we can say select star from stock, order by symbol. If we do that, you'll see it's ordered by symbol, ascending order, Apple, AMD, Microsoft, and Tesla. But what if we want to sort the other way, right? So order by symbol, descending. I can say TMA, so it's in reverse alphabetical order. And so you think of how this works on a web application, right? If you had a table of some sort, right? A lot of times you end up sorting by title or sorting by date. So when you click the heading of a table, let's see if we have one of these tables somewhere to show as an example real quick. See how I can sort by percent change, sort by name, and so forth. So think about how that might work in SQL, right? When I click the heading to sort, we could send the order by, we could change dynamically the order clause here, right? So I can sort by symbol ascending, click the table heading again, sorting it ascending, right? And then if I wanted to order by a different field, I click a different table heading, and maybe I want to sort by ID, descending, right? And go 4, 3, 2, 1. So that's how you sort in SQL, right? You can also count and aggregate. So I can say select count star from stock, and that will count the number of records. And I spelt the word select wrong. But now if I do that, I can select that there are 4 records total in the database. And so I can combine count with where, and I can say select count star from stock where company like percent icro, like one of those things we did earlier, and it'll count the number, and that'll be 2. And then these get more and more powerful. So I can like select all prices between 2 dates, so between January 2nd and January 15th, where the closing price is above the 200-day moving average. So you can build SQL queries to select very specific records that you want to operate on, and we'll talk more about that later. But that's the basics of an SQL select statement. So we've inserted records into our database table, and we have selected and retrieved them out of our table. All right, so we talked about how to create and read data. Let's talk about how to update data, and sometimes we would have to do this. So you update data all the time, right? You edit a status update, you change your name, you change your password, you can change the caption on a photo, all types of stuff you update on the web, and you click a button, and then it runs an update query on the back end to update that data in the database, and then that update is reflected to all of the other users or yourself or anyone else that sees that data, right? And so let's talk about the syntax for an update query in SQL. You use the update keyword. You specify the table you want to update. So we're updating the stock table, for instance. And maybe you want to set the company name equal to a certain value. And then you give it a where clause to say where update the records that match a certain condition. And so, so we have some simple tables right now. So when would we really want to update data? We could update old prices technically. Let's pretend we missed some bars for some reason. There was some missing data. We could go back and backfill that data, or we got some bad price information for whatever reason. We could go back and update that data, or if there was a stock split, for instance, and we wanted to update it to reflect the value of the split price, or we could update the stock table itself. And when would we update the stock table itself? Well, companies change names all the time. Google changed to be called Alphabet as the parent company, and stocks change symbols all the time. You might not think that's very common, but if you go to like NASDAQ.com here, stock symbol change history, you can see just this year, April, May, there's stocks that are changing names and getting delisted, and companies getting acquired all the time. So I think like E-Trade probably got acquired, right? And Morgan Stanley acquired E-Trade. And so at the time, when we snapshotted and stored these symbols that we cared about, E-Trade was a symbol and then it wasn't. So there's tons of changes there. So how do you write an update statement to handle that? So let's do select star from stock. And that's all of our stocks, right? And let's say AMD, for some reason, got it acquired by NVIDIA, right? We might want to delete AMD stock, for instance, or let's say AMD changed its name to AMDA, like Advanced Micro Devices Association. I don't know. So let's say we changed the symbol, right? So we could do an update statement. So we write update. We specify that we're updating the stock table, and then we write set, and then we just set different values, right? So we can set name, or we can set symbol equal to AMDA all of a sudden, and then where ID equals 4. So we could say only update the one where ID equals 4, and you see it's now AMDA. This where clause is very important because if I didn't have the where clause, it would update every record in the database. And so let me make that mistake real quick. Update stock set symbol equals AMDA. Oh, good. We have our unique constraint. Remember when we created our table, this actually prevented us from doing this. So this is a nice data management feature. It says unique constraint failed stock symbol. So we specified that every stock symbol had to be unique. Star from stock. And so our update here failed because our relational database tried to preserve the integrity or the consistency of our database. So a CSV file, it would have just got wiped out. But we specified this, the constraint failed, therefore the update failed. So that's another nice thing about relational databases, which I mentioned in one of the articles. I said you can have things happen in a transaction, and if an exception or error occurs, you can say roll that back, something went wrong, and then abort the transaction basically and restore things how they were. So nice benefit here that we ran into. So let's say we updated and we set the company name for every stock equal to Advanced Micro. That would be bad because we have no constraint there. And so if we select star from stock now, every company in our database, if you type things directly in your database, it can be error prone if you make mistakes like that. So you don't want to make mistakes like that. And so I've accidentally updated every record in the database. And so let's go ahead and set those back real quick. So we'll use our update statements and just say set company equal to Apple Inc., where ID equals 1. Set company equal to Microsoft, where ID equals 2. And set company back to Tesla, where ID equals 3, and so forth. And let's just set AMD back how it was. So if you want to update 2 columns at once, so I'm going to set the symbol equal to AMD, comma, the company equal to Advanced Micro Devices, where ID equals 4. And I've updated 2 columns. And my stock table is nice. It's back where it was. And we fixed all our problems by updating our data. Okay, that's an update statement. That's really all you need to know. So the most sophisticated inserts are usually pretty much the same. Updating, deleting, you're just writing a query like this. So the most sophisticated queries are selects. These can actually be dozens of lines if you want to select things of very specific records or aggregate in very specific ways. So select, you'll spend a lot of time learning how to write good select statements that are fast, where you join across multiple tables and relationships and aggregate data together and so forth. So we'll talk a lot more about select statements soon. Okay, so we know how to create records, read records, update records, and now how do we get rid of one? So we can delete from stock. So delete from stock where ID equals 3. Right, and if I do that, my stock with an ID of 3 is missing. And if we wanted in our database constraints, we could also say on delete cascade is a special thing a relational database can do. So we could say if I delete a record with primary key 3, then any other record that references that should also be deleted. So I didn't specify this in this database yet, but it's something you can do. So a way that would be useful, let's say you have an employee of a company and you delete their user record, you might want to delete every record of existence of that person. You want them to disappear off the planet. So anytime they've logged in, any personal information, let's pretend it's a hospital, you want to protect some data, wipe it out, right? You delete the user record, you should delete everything related to that user, their bills, their health records, all that kind of stuff. So think of a lot of relationships, deleting one record and then cascading out and automatically deleting any records related to that thing, which is more power that you can't get in like a flat CSV file. For instance, you'd have to go write code to get rid of those records wherever they exist. But if you're a company like Facebook, you probably never really delete people's data. You're always hiding it and pretending you deleted it or something. So anyway, you can, yeah, that's how you delete records. And so yeah, that's it for this video. We covered in the first tutorial how to create tables, and now we know how to populate and manage rows in those tables using SQL. And so we've learned some basic SQL operations. And so you'll notice here that we wrote all of these queries by hand, which is great to learn. And often you have to jump in your database and do something like this sometimes in an emergency. But what we're going to do in the next video is show you how to use Python to execute these queries. So the reason why that's important is because we're not going to go write insert statements for like thousands of stocks, right? We're going to have Python loop through a file and then have it dynamically generate these insert statements, run them all against our database, and insert all those records. And then we're going to hit our Yahoo Finance with Python. So we'll loop through all of the symbols in a loop, and then we'll get all the price data, and we'll insert thousands of price records. And that's not going to be that many lines of code, a couple dozen lines of code maybe, to write a couple loops and insert and populate these database tables dynamically. So stay tuned for the next video, and I'm going to show you how to connect Python to a SQLite database and execute queries using Python's SQLite module. So thanks a lot for watching, and stay tuned for the next video.